You can also use the zero product property to solve equations of the form ax squared plus bx plus c equals 0 if the quadratic expression ax squared plus bx plus c can be factored. Example problem 2, solving by factoring. Now note this is a multiple choice question. We have answer choices A, B, C, and D. And the question is, what are the solutions of the equation x squared plus 8x plus 15 equals 0? Well, to solve this, we should factor the expression on the left, if possible. All right, so having rewritten the expression, just the expression on the left of the equals and the 0, putting in the infrastructure for our factored form, substituting in first terms of x, because we know when we FOIL we'll multiply first terms to get x squared. Now we seek out constants, or last terms for each of these binomials, and they need to be last terms that when multiplied equal 15, and when added equal 8. 3 and 5 come to mind. In no certain order, I'm going to write plus 3 there and plus 5 here. And then, knowing that this expression is really still equal to 0, I guess there's no good reason that I shouldn't have written that here. Now I consider the zero product property, which, recall, says if this stuff times this stuff equals 0, then either this stuff equals 0, or this stuff equals 0, or maybe both of these stuffs equal 0. Considering what x value will make this stuff on the left, this binomial, equal 0, well, off the top of my head I think, well, negative 3. Negative 3 plus 3 is 0, and so my first solution, x equals negative 3. Recall how this works. When x equals negative 3, we would substitute in negative 3 for x. Negative 3 plus 3 is 0, and recall that will be multiplied by, we can do this, negative 3 plus 5 is 2. Note it doesn't really matter though. Like I've said before, 0 times who really cares, doesn't matter, you don't even need to do the work in a problem like this, it's going to equal 0. And that's, remember, the zero product property at work. So x equals negative 3, yeah, we've checked it there, it works. So next we consider what value of x makes this second binomial equal 0, negative 5. And recall substituting in negative 5 plus 5 is 0, times whatever, it's going to equal 0. So there are our two solutions, negative 3 and negative 5, which, looking at our answer choices, negative 5 and negative 3, that's answer choice A. And a chance to show that you have got it. Question 1 of 3. What are the solutions of the equation m squared minus 5m minus 14 equals 0? Recall you should factor the expression on the left and then use the zero product property to determine solutions, or values of m, that make the equation true. Work carefully and make your selection from the choices below. And question 2 of 3. What are the solutions of the equation p squared plus p minus 20 equals 0? Work carefully and make your selection from the choices below. And got it, question 3 of 3. What are the solutions of the equation 2a squared minus 15a plus 18 equals 0? Work carefully, make your selection from the choices below. Before solving a quadratic equation, you may need to add or subtract terms from each side in order to write the equation in standard form. Then factor the quadratic expression. Here's a good example. In problem 3, writing in standard form first. The question says, what are the solutions of 4x squared minus 21x equals 18? Recall that in this section, we've relied upon the zero product property when solving quadratic equations. Note we have an equals 18 on the right-hand side. What we really would like to see is an equals 0, like we saw in the previous example problems. In order to make that happen, you probably recognize, we just need to subtract 18 from both sides of the equation. That gives us that equals 0, which will then allow us to solve this problem much in the way of the previous problem. So our new equation will be 4x squared minus 21x minus 18. Well, we seek out a common factor, a greatest common factor that can be factored out. 2, no. 3, no. We may just be stuck with what we have. That's okay. So our next step is to factor this expression. So we set up our infrastructure, parentheses, to hold our binomials. And we find that for x and x work as first terms, giving us 4x squared, and also that positive 3 and minus 6 give us factors that, when multiplied, equal 4x squared minus 21x minus 18. Now, what values of x make this equation true? First, consider what values of x make the left binomial equal 0. Well, we can set up the equation, 4x plus 3 equals 0. Subtract 3 from both sides to find that 4x equals negative 3. Divide both sides of the equation by 4 to find that x equals negative 3/4 to be one of our solutions. A quick check against the book's work to make sure I'm on track. Looks great. And then our second binomial. What value of x makes this binomial equal 0? Well, that's pretty simple. That's 6. 6 minus 6 is 0, and then the rest would be history. So, two solutions, x equals negative 3/4, and x equals positive 6. And a chance to show that you have got it. Part A, what are the solutions of x squared plus 14x equals negative 49? And part B, a reasoning question. Why do quadratic equations of the form x squared plus 2ax plus a squared equals 0, or x squared minus 2ax plus a squared equals 0 have only one real number solution? You may want to think about what that means in terms of the graph of these quadratics, maybe the vertex of that parabola, and consider also the x-axis.